Hello world, my name is Shitij, this is the coding tree, and today we're talking about recursion. Now, as a heads up, before we get into recursion as a concept can often be pretty difficult. Due to its very nature, it's difficult to conceptualize in one's mind. So, don't worry about it if you don't completely understand it at first. You'll get it eventually. With that out of the way, now we can talk about recursion. So, up until now, we've been using loops, while loops and for loops to repeat random segments that we need to repeat in our code. However, sometimes while and for loops don't always cut it. And other times, it's just simply better to have an alternative. That's where recursion comes into play. So, what is recursion? Well, simply put, it's the act of calling a function within itself. When you write a recursive function, remember the keyword function, just the various methods that we use in Python, you call that function within itself. As an example, we can use this simple program, a program that has a recursive function in it because this function calls itself, within its code. Note, this program doesn't really serve any practical purpose. All it does is do this recursive call. So we're just going to build this program within the context of the recursive call. So first, all I'm going to do is define a function. It could be any function. I'm just going to make sure that it has one parameter of x, or any letter, but just one variable that you're passing in as a parameter. Now, we're going to do two things of note. First is to actually implement the recursion and the recursive call. What's a recursive call? Well, it's simply the line that calls the function within itself. So when we do this, we're going to add an if statement. This if statement, all I'm going to make it do is check if x is equal to 0. So here, I'm going to check that, and then within the if statement itself, I'm going to make my recursive call. My recursive call will simply be calling the function, and instead of passing in x directly, because if I passed in x, it would just be an infinite loop if x was 0, right? If x is 0, I'm checking if x is 0, and passing x is 0 back into the function just to check again. That's an infinite loop. We can't have that. That's why I'm going to pass in x plus 1. I'm changing the parameter of x so that if I do pass in 0, when I make the recursive call again, the parameter won't be 0. And I'm going to return that value because I can return the value that I get when I make that function call. That's what I'm going to return. Next, I'm going to add one more thing, a base case. What's a base case? Well, it's simply when I'm telling the program to stop the recursion. So I'll just do if x is not equal to 0, then I can stop and just return x. Instead of returning a recursive call, I return simply the parameter itself, and that becomes my return output. Simple, right? All I'm doing is adding another condition to check if we're done with looping. This is actually a really important concept because it helps us prevent infinite loops. Because if we don't have our base case, then we run the risk of continuously making a recursive call without any stopping point. That is going to cause several different errors, including several different runtime errors, which are going to be kind of difficult to solve. Thus, it's important to remember your base case. So now I'm going to call the function itself, not a recursive call, just normally calling the function, and I'm going to pass in a parameter of 0. I'm going to print the output and see what I get out of that function. I get 1, even though I passed in 0. Why is that? Well, something really simple is going on here. What the recursive function does is first check if my parameter that I inputted in is 0. Because I did input in 0, it is 0. So it goes inside of the if statement and then makes the recursive call again. This time, it makes the recursive call with the parameter of 1. And the parameter of 1 simply returns 1 because it goes to our base case. It doesn't go to our initial recursive case. Thus, we make the call again, and this time it returns 1. So then, in the first time that we made the call, we're returning 1 in that because the output of function x plus 1 is equal to 1. So thus, in our initial call, we're returning 1, and thus we're printing out 1 when we call the recursive function outside of the recursive function itself, when we call it normally. So next, you're going to write a pretty difficult function, at least compared to what we just did, in which you're going to take an input and then return the sum of all of the numbers that lead up to that input. So if I input in 10, I would return 10 plus 9 plus 8 plus 7 till 1, you get it, which is equal to 55. You're going to write a recursive function for that. Now I know this can be done iteratively, or which means through loops as well. However, it's important to learn recursion, and this is a great example on how to do so. But before you start, I'm going to give you a few different hints to help you in this process. First, take a look at this code here. This is how you would do the process that I'm describing without a recursive call, if you were just to do it iteratively. It's pretty simple, right? See if you can replicate this behavior with recursion, but without loops. Second, I want you to think about what your base case would be. When are you going to stop making this recursive call and stop the function? That's what you need to be able to know how to do that, so you prevent an infinite loop. Remember, all you're getting as a parameter is the number itself, and you can't loop all the way up to the number, so you're going to have to go backwards. But you're also going to need to know how to stop going backwards. Finally, there's one last thing I want you to think about. What happens when you pair your recursive call with addition of just a normal variable? Let's say your parameter, and you pair that addition with a recursive call inside of a return statement. Think about how that works and use that in your program. All right, now pause the video, see if you can figure something out. It's totally fine if you can't, and I'll let you know in just a few seconds. All right, that was a bit challenging, right? It's okay if you didn't get it, but now I'm going to explain the code and you can see how you did. So, first off, how do we exactly make sure that we're adding all of the numbers from, let's say as an example, a parameter of 10 down all the way to 1 without going to the negatives? And it's actually really simple. I'm just going to add my base case first, and my base case is going to check if my parameter is less than 0. If it is, then I know that I can't exactly continue doing that. And as such, if it is, I'll just return 0 from return 0 and be done with it. That's my base case done. That's to ensure that we don't start adding negative numbers to our sum total, because that would just ruin everything and lead to an infinite loop. Now, what about the recursive case? How do I know when to recurse and how to recurse? Well, it's actually, again, pretty simple. All I have to do is return x plus, calling the function again, x minus 1. What does that do? Well, what it actually does is return x. So let's say 10 is my first input. 10, and then makes a recursive call with 9. And then 9 returns 9 plus the recursive call with 8. Then 8 returns that call returns 8 plus the recursive call with 7. 7 plus the recursive call with 6, and so on. Eventually leading to adding 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 plus the recursive call for 0. Add 0, makes one last recursive call, and checks if x is less than 0, which if it is, it'll just return 0 and make no more recursive calls. We're ending the recursion there, and what that does is, to put simply, add all of the numbers from 10 to 0. Pretty simple and pretty elegant solution to this problem. Look at that. That's a purely recursive function that gets the exact behavior we were looking for. But now I know. You must be wondering, why should we use recursion versus an iterative call? Well, the answer is simple. Some questions are just easier with recursion. Now, I know this might sound a little bit weird, but in a future video, we'll take a look at another example of a function that we can write recursively that'll be not only pretty easy to write, but also efficient. We'll take a look at that soon. But for now, you've just added another tool to your tool belt of programming concepts. This time, it's recursion, and it'll allow you to write better code, better loops, and simply make more elegant solutions to problems. That's all for now, folks. I hope you enjoyed, and I hope you learned something. If you did, make sure to leave a like, and if you want to continue your computer science journey, make sure to subscribe. With that, thanks for watching.